today I'm looking at this Lloytron AA battery charger. It's mine, just stopped working the other week. I'm going to take it apart, see if we can fix it. So the problem I've been having is when you plug it in, the screen comes on, but then when you put a battery in, nothing happens.
Yes, it does.
It doesn't tell you anything's going on. There's clearly something not right. So let's flip it over and see if we can take it apart. Help if you use the right size bit. There we go. Okay, now it's out the case. Let's have a closer look, see if we can figure out what's going on. And straight away, you can see there, let's bring it in a bit. This top corner is a completely different colour. There's a few capacitors and things around there. One of the best things to do would be to get this under the microscope so we can have a look at what's going on a bit closer up. Let's have a little look around this thing. We've got the power coming in from there, that's something to point with. A fuse up there. A couple of capacitors on the input side. There's a little capacitor down there. And it looks like bridge rectifier. 4 diodes. Some kind of IC controlling the switch mode, power supply. Diode capacitor there. It's a bit more obvious a discoloration on the board compared to, say, up here. It's very brown, and there's this glue which has been used to stick down this little transformer. It's all gone brown where it's overheated. So I'm guessing our problem's up here somewhere. Now it did switch on, the screen came on, but it didn't do anything else. So I think this side is probably all working all right, and then everything past this. Look at this line here, gap separating the mains input side to the lower voltage side over here. So I think we should concentrate on looking here. Let's have a look at this diode on the side. Get the sharps focusing. So with JH, so it's an SR1040 diode, probably a Schottky. We'll have to check. We'll test that too. Right, let's see what's going on. As the power's getting through to the secondary side, it makes me think that we haven't got a problem over here. It's more likely to be over here. Because the screen is coming on, it is doing something. And it also matches this burning on the board.
Nope.
So I think we'll start our investigation over here. Get out the multimeter and start testing some things. Right, the first thing I want to check is this Schottky diode in the corner. Let's see what that says. Got it on diode mode. .22. That's up the leads. I think, okay, that seems all right. I think 0.2, 0.3 is about right for Schottky. Let's have a look. Switch to capacitance and have a look at these capacitors. Okay, so we've got one up here. 45.2. That's supposed to be 47. So that's absolutely fine. Let's try this one in the middle here. 23.4. What's it supposed to be? 22. Absolutely fine. Let's have a look at the big one. 1,000 microfarad. It's what it says. 847. I mean, that's a little bit off the 1,000, but you can expect 20% variance on these. So really, it's still okay. I think what I'm going to do now is take that shortkey diode out and test it out of circuit. Put a little bit of flux on there. Not this old solder. This is really good, by the way. It's only like £1, £2. And you just put it in the end of the tube. It gives you really precise application. And it's much easier than trying to use the plunger like you normally would. Okay, there we go. Let it cool down a bit, and we can put it in the tester. See what's going on with it. These are quite good. I can put these from here instead. Close the door, and then you've got the little clips you can attach onto the component. Turn it on. Diode. Yep, so it's the same as the multimeter did. I think I might just try swapping out this diode and see what difference that makes. Before doing that, I just noticed that on the back there's a couple of diodes that I missed here. There's one there, there's a D Zener diode. Before replacing this, I'm going to check the read code first. It's got the multimeter and diode. Switch the leads. Point 6, yeah, fine. Zener. 0.6. Switch the leads. 1.6. Got no idea if that's right. Gonna have to look that up. Okay, so I just looked up testing Zener diodes. It involves taking them out on batteries and resistors and stuff, and I'm not doing that.
That's too much work.
We tested it on diode mode, but I think now we'll just test it at continuity and see what we have. No, that's resistant. Let's just try again. Test it. Right, there we go. Okay, nothing that way. Good. Switch it around. Nothing that way either. Okay, so I've got some replacements. The original is the new one. I couldn't find the exact part. It seems it doesn't exist anymore, discontinued. So based on the data sheets, they're pretty much the same thing. So hopefully that'll work in its place. So this new one is, you can see, 0801A, where the old one was the SR1040. So I'm going to pop that in and see if it makes a difference to our problem. Which will get it the right way. Luckily there's a picture on the board and on the diode. Okay. I reckon I'm going to give it a try. Nice. Ready. No. Exactly the same. I think we need to do a little bit more investigation. I think I'll plug it in and we'll see if we're getting the 5 volts that regulator there, and just see what other voltages there are around. So I've gone back under the microscope so we can have a look closer up. I'm going to find out what these chips are that are on here, and also I want to test the voltage at the regulator that we found earlier. Make sure that is 5 volts. So what we got? Big one in the middle, 903A. Whatever that is, probably your controller for charging, I assume. What's that? 9926A. 9926A. Keep that one a bit of a clean. Let's turn it around. And then 358. Before I look at those chips, I'm just going to plug it in. We test that regulator, see if we're getting 5 volts. So we want to get here, 17 volts. Okay, and then from here to here, 5 volts. That all seems to be working okay. Yeah, I assume that's probably powering these ICs over here, but now I'm going to go and have a look, see if I can find out the pinouts of these, and we can do some more measuring. I just had a quick look at what all these chips are. The 903A, couldn't find anything on. The, is it 9926A? 2 of those. They're just dual MOSFETs, and then that's just a op amp. To be honest, I don't really feel like there's anything wrong here. But what did cross my mind is I didn't check if there's actually any output on these terminals when it's plugged in, because it might actually be working, but it could be a problem with the display, not the actual charger itself. Got the multimeter on voltage DC. We're going to the negative terminal there, positive there, still there, 3.6 volts. Next channel, 8.6, next one, 8.6, next one, 8.6. Okay, it's working. So it's something to do with the screen. Let's take the screen out again. Before we can test the continuity, I'm going to scrape off some of this glue that's on here, so I can get a good reading with the multimeter. Okay, still looks pretty grim, but at least it's clean, and I can use the multimeter to test between here and then these points here on the board. So we have the multimeter on continuity, and let's check these connections. Yeah, okay, that's all fine. I mean, it could be something ridiculous like these contacts are a little bit dirty, so it's not making enough of contact with the screen in the case here. I mean, you clean it, try it, see if it makes a difference. Running out of ideas really at this point. No. I've spent some time looking over this. Everything seems fine. Quick check of all the MOSFETs. Everything seemed fine. I had the idea if we could hook this up to the scope, and then we can have a look at these 4 lines here, which are connected to the screen. And then up top where we've got 5 volts, 2 5 volts and a ground, and they're all fine. So I think what I'm going to do is check out these lines, see if there's anything going on there. If there is something there, then to me, I think it's this, just in there, I think there's something wrong with that black chip there, which is sort of a chip under a blob of resin. There's not a lot I can do about that. Let's see what the scope has to say. So it's connected up to the scope now. What I want to do is test these lines here, because these are the output from this chip, which goes to the cable around here to these. And we've tested the cable, so we know it's fine from there to there. So if there's any data, so to speak, coming out of here, then I think that suggests to me that it's that black chip that has something wrong with it. So let's have a look. The first one is connected to there, and we've got solid 5 volts. And where does that go? All the way around to the top one then. So yeah, 5 volts. This one is also 5 volts. This one, that one's also 5 volts. Let's try the next one. Okay, so there is something coming out of there. Next one. Yep, and there too. And on the last one too. Now let's just check that they do end up here as well. Yep. 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 So I reckon it's knackered. Matt here, just going to talk over myself. As you probably guessed, there wasn't actually an awful lot wrong with it apart from the screen. I thought it was a bit of a pointless video, but then I realised it's a good example of why it's really important to test things properly before you start taking them apart and taking components out, placing things. Because it was working fine, just the screen wasn't displaying anything. You can see from the videos here that it does actually charge batteries. The screen comes on when you put a battery in, which is what it always used to do. And then once the batteries are charged, the screen turns off, again, like it always used to. So I think I'll put this one down to a learning experience and then move on to something else. Thanks for watching. I'll see you in the next one.